All right, so we're moving on to section 7.2 today. And what this is going to do is introduce four more of the rules of implication to us. Everything is essentially going to work like it did in the first section in 7.1. But in addition to the modus ponens, modus tollens, hypothetical syllogism, and disjunctive syllogism, we're also going to have these four new rules. Constructive dilemma, simplification, conjunction, and addition. Now, constructive dilemma you're already familiar with from chapter 6, but just as a reminder here again, we have the basic idea of a constructive dilemma that there are two conditional statements joined together by a dot. That's your first premise. Your second premise, the two antecedents joined together by a wedge. In your conclusion, the two consequents joined together by a wedge. And as I explained last time, it's basically like two modus ponens that have been stuck together. If square, then circle, square, therefore circle, and if triangle, then diamond, triangle, therefore diamond. So this structure, this form, is a constructive dilemma, CD, and it is always a valid form. Now the other three are very easy and very useful. First, we have simplification. Simplification basically says that if you have any two things stuck together on a line with a dot between them, okay, this only works for the dot, for the and, then you can take one side, get rid of the other. So if you're working a problem and you have A and B, but you only need A, you can use simplification to keep the A, get rid of the B. Okay? So anytime there's the dot, you can use simplification. Conjunction is basically the opposite of simplification. If you have two things together on a line, but you need them conjoined, you can use the dot, and again, only the dot, to join those two together. Okay? So if I have A and B on two separate lines, but I actually need A and B, then I can use conjunction to put those together. The most useful of all probably is addition, which basically says that using the wedge, you can add anything you want to into your equation. Okay? So if I need A or B, but all I have is A, then I can use addition to add that B into it. Again, it's only going to work with the wedge. Why? Well, think about your truth tables. Right? The only time that the wedge, the disjunction, is ever false is when both sides of the equation are false. Well, we've already asserted that this line here is true, so it doesn't matter what I add onto it, it's not going to alter the truth value of what's presented there. And, again, you could go back and look to your truth tables to understand simplification and conjunction as well. The only time that the dot, the conjunction, is ever true is when both sides are true. I've already asserted that both of these are true, so obviously this will be as well. And here, because the conjunction, square and circle, A and B, however you want to put it, is true, then either side I pull out is also going to be true. Okay? So these are the four new rules that you get to play with in 7.1. Constructive dilemma, simplification, conjunction, and addition. Looking through the chapter, which you're welcome and encouraged to read on your own, there's a number of different examples, but the easiest way to do things is kind of to just jump into it. And so I want to take you straight to the homeworks. The exercises for 7.1 starting around page 406. Now, with these, Section 1 is going to work just like the Section 1 in the last homework. You're going to be given a series of premises, and you have to figure out how to draw the conclusion. But this time they make it a little bit easier for you because they are going to give you what they want you to do from these four forms. So let me just do a few of these here, help you visualize what's going on. So the first one, we've got S or H, line 2, B and E, line 3, R then G, Line 4 is what we were supposed to figure out, and they want us to use simplification. So you know for simplification, you need to find two things joined together by a dot. So that's here on line 2, B and E. The wedge doesn't work for simplification. The horseshoe doesn't work for simplification. Only the dot. So B dot E could very simply become B from line 2 through simplification. Number 2, we've got N, then T, and F, then Q. Line 2, N, then R, or F, then M. Line 3, N, or F. And line 4, they want us to figure out, but they tell us they want us to use constructive dilemma. So for constructive dilemma, you need two conditional statements joined together by the dot. Line 2 has the wedge, so you know you're not going to use that. So we're going to be using lines 1 and 3 to form the constructive dilemma. So two conditional statements joined by the dot. The second premise, the two antecedents joined by the wedge. And so the conclusion we want to derive, the two consequents joined by the wedge. So T or Q. Number 3, we've got D, we have W, and we're supposed to do a conjunction. Well, it doesn't get much easier than that. We're only given 2 lines, so we know we're going to use lines 1 and 2. Conjunction, you take those 2 lines, use the dot to join them together. It becomes D dot W. And if you thought it couldn't get any easier, it does. Here they want us to use addition. So we've got H on line 1, so you know line 1 is what we're going to use. We can take that H, and with the wedge, we can add anything we want to on there. We're going to add A, B, Q, if A then P, if R then S then Q. Whatever you would need to put on there, you're certainly free to be able to do that. Okay? So that's the basic idea. Let me show you one more here at number 5, just to clarify something. We've got R dot N or K. We have G and T or S. We have Q and C, then J and L. And here they want us to do simplification. Okay. Well, simplification, again, any time that you have anything joined together with the dot, you can use simplification. And again, remember the conditional is the only one where order matters. So line 1, what most people would probably do instantly would think, all right, line 1, R and N or K, we'll make that R from line 1. But you could just as easily make that N or K from line 1. If you look at line 2, you've got G, N, T, or S. Well, even though it's in the parentheses, it's still 2 things joined together by the dot. So you could choose to make that G, getting rid of the T, becomes G or S. Or you can keep the T and get rid of the G, it becomes T or S on line 2. With line 3, Q and C, then J and L. I mean, there's a lot of possibilities there. You could keep the Q, get rid of the C, it becomes Q, then J and L. You could keep the L and get rid of the J here, and you'd have Q, N, C, then L. Okay? So, I mean, anywhere that there's the dot, you can use that simplification. So don't think, like the book seems to make it appear, that it has to be just like one single little letter or somewhere. Anywhere the dot is, you can use it, and that makes it a very, very useful tool. Okay? There are 5 more on section 1 of 7.2, 6 through 10. So you guys may as well do those, and we'll make that the first part of your homework. 7.2, section 1, 5 through 10. Section 2 is going to work similar to what we had the last time. So let me just throw one of these up here for you. We have on line 1, G, then N. Line 2 is going to be G and K. Line 3 is missing, and line 4 is the conclusion we want to reach this time, which is G or T. Okay. Now, as you recall from section 2 of 7.1, the idea was to figure out what was missing in order to derive that conclusion. The difference is now, instead of just putting it there, they want you to say how you got it. They want you to use one of these rules to derive it. So if we look at what's here, we've got if G then N, G and K, line 3, and what we want is G or T. Well, with that wedge in the conclusion, there's really two possibilities. It could be a constructive dilemma that would give you that, or an addition. There's nothing up here that leads towards the idea of a constructive dilemma, so we have to think in terms of addition. So in order to get G or T through addition, I would need G here on line 3. And so the question becomes, how do I do that? Well, on line 2, I've got G and K, so using simplification, I can keep the G, get rid of the K. So from line 2 through simplification, I have line G, I have the conclusion there. So this is the way it would work. Line 1 we don't need, but from 2, G and K, we could simplify that to G, and then use addition to add the T. Okay. Let's do one more here. Number 2, we've got not A. We have A or E. Line 3 was the empty one. And line 4 is not A and E. Okay. Well, looking at the conclusion that's presented here, not A and E, the only way I'm going to get that is through conjunction. I would need not A on one line and E on the other. We've already got the not A, so I need the E for line 3. That way, lines 1 and 3 can give me that answer through conjunction. But the question becomes, how do we get E? Well, lines 1 and 2 make a disjunctive syllogism. It's either A or E, it's not A, therefore E. 1 and 2, disjunctive syllogism. Okay? So that is the basic idea there for section 2. So I'm going to let you try the rest of those as well. So that's 3 through 10 on page 407, 7.2, section 2, 3 through 10 on those. And then finally at section 3, we are putting it all together again in working proofs. So let me just do a couple of these with you. I'm going to start. Let's try number 3. We'll see E, then A and C. Line 2 is A, then F and E. Line 3 is E, therefore F. So it's working proofs in the same way that you were doing in 7.1, except now you've got 8 rules to play with rather than just 4. And that actually really can make it easier in many ways. So looking at this, how are we going to do it? Well, same as before. Forget about the conclusion for a minute. Look at the 3 lines. What can work together? 1 and 3 would make a modus ponens. If E, then A and C. E, therefore A and C. 1 and 3 modus ponens. Then, if I take A and C, I can use simplification to make that just A. And then 2 and 5 would also be a modus ponens. If A, then F and E. A, therefore F and E. 2 and 5 modus ponens. And then for line 7, if I take F and E, I can use simplification to make that just F. From line 6, there's the conclusion we wanted to reach, and so we've just proved that one to be valid. Okay. Let me do one more with you here, just as an example, and we'll make it one of the later ones here perhaps. So how about number 9? We have U or W, then T, then R. Two is U and H. 3 is, I keep losing it, not R and not J. Therefore, the conclusion we want to reach would be U and not T. Okay. Well, looking at this one, it sometimes helps to look at the conclusion. And so when I look at the conclusion here, I can see U and not T. So I know the final step has to be a conjunction. Somehow I've got to get U by itself on one line and not T by itself on another. Well, getting U by itself is easy. On line 2, you've got U and H. So I'm just going to use simplification to make that U. Now I've got to work on getting the not T. Well, you can kind of visualize it here already. T then R, not R, therefore not T. But we've got to get that T then R by itself, right? So how do we do that? Well, it's in this conditional statement here. So the best way would be through a modus ponens. To use a modus ponens, I would need the antecedent, U or W. Well, fortunately, here at line 4, I have the U, and with the rule of addition, I can add anything I want, so I'm going to add a W. Make that U or W from line 4 through addition. And now 1 and 5 make a modus ponens. If square, then circle, square, therefore circle. T then R, 1 and 5 modus ponens. Then we need the not R. So up here at line 3, not R and not J, we can simplify that to not R because of the dot. And 6 and 7 make a modus tollens. If T then R, not R, therefore not T. And so now we've got the U on line 4, the not T on line 8. All we have to do is use conjunction to stick those together. 4, 8 through conjunction. And that one is proved. Okay? So that's basically all there is to it. And so I'm going to unleash you on some of these. So of course I'll put this up on Blackboard as well, but the homework for this section, 7.2 section 1, you're going to be doing 6 through 10. 7.2 section 2, you'll be doing 3 through 10. And 7.3 section 3, you can do 2 through 20 even. Okay, so section 1, 6 to 10, section 2, 3 through 10, and section 3, 2 through 20 even. Like always, if you have any questions or concerns, feel free to email me and I'll get back to you about that. Perhaps do another video if needed to clarify anything, any concerns that you might have.